Hello. We're going to solve a trig equation where we have two different trig functions involved. In the previous examples, we always just had one function and we tried to get that function by itself. But you see here we have tan and sine involved. Several strategies. One is just to try to simplify or reduce the expression. So like maybe, rewrite tan as sine over cosine. But you see that's really not going to simplify our lives. It's gonna make a sine squared, and that doesn't help. And so some cases maybe a sine would cancel or something, and then that would be a good strategy. But in this case, what we really want to notice is that there's a tangent x in each of the terms. And so that indicates to us we can factor out a greatest common factor of tangent x. And I'm left with sine x minus 1. So you see if I divide tangent out here, I get sine x, divide tangent out here, I get 1. And now we have really broken this up into two smaller parts using the zero product property. We know that either tangent of x has to equal 0, or we know that sine x minus 1 has to equal 0. And from here, we can treat these separately and solve. So if we think of tangent, and we think of tangent being the y value over the x value, we're looking for where do I get 0 on my y value. And so on my circle, that's going to happen here and here. I'm going to solve this one in radians. So we're going to call this 0 and pi. And then over here with sine x minus 1, we just solve, we get sine x equals 1. We think about sine as y over r, so we want to find where it's 1 over 1. Where is my y value 1 and my radius 1? Well, that happens up here. Okay, and so that's pi over 2. And so my final solution then, I've got three answers. You can write this in two ways. I'll write it as 0 plus 2k pi, where k is an integer. I can also have pi over 2 plus 2k pi, and then I have pi plus 2k pi. And so this just takes care of the coterminal angles. So 0, and then I add 2k pi, it's going to give me that solution again. Add 2k pi, it's going to give me that solution again. Same way with pi. Add 2 pi, I get another solution. Add 2 pi, another solution. Pi over 2 here, add 2 pi to it, and we keep doing that to get more solutions. Now, you may notice that these are only a pi apart. So if I add pi, I get this solution. Add pi, I get this solution. Add pi, I get this solution. So an alternative answer, this answer is perfectly fine. An alternative answer is to say that x equals 0 plus k pi, and x is equal to pi over 2 plus 2k pi. This is equivalent to that. Okay? All right, so the key here was factoring, and so we're going to take a look at this next one, which also involves factoring. So you've got the equation here. We're just looking for 0 to 360, and it asks, what form is this trig equation in? Okay, now what I'm really getting at is, do you see the squared here in the u? If these were x's instead of cosine, if I gave you 2x squared equals 1 minus x, all I really did is I replaced cosine x with just x. If I did that, I guess that's cosine u, I replaced with x. You would probably know how to solve that. You would say, okay, I need to get the x squared and the x and the constant term on one side, get it equal to 0, and then I want to try to factor that. So that's going to end up being plus 1 minus 1, and then I'm going to split them up. I know 2x minus 1 can be 0, or x plus 1 can be 0. And so I know x can be 1/2, or x can equal negative 1. And that's actually exactly what you're going to do with this problem. Okay, same strategy. You can treat it like this, and then substitute, and then come back, where you say cosine u equals 1/2, and cosine u equals negative 1. Or eventually you'll probably not show that, and you'll just kind of do it in terms of cosine. So whatever works for you. I see that 2 cosine u times cosine u, this times this is going to give me this. And then to get -1, I need +1 and -1, but I also need a positive cosine u in the middle term. So if I put a +1 here and a -1, then this is going to give me 2 cosine u minus 1 cosine u, which gives me the cosine u that I need here. And then I also have the -1 times +1, which gives me the -1. All right? And now I just split these up. Since this is multiplication, if this whole term is 0, 0 times anything is 0. And if this whole term is 0, 0 times anything is 0. And so here we get 2 cosine u minus 1 equals 0. Cosine u plus 1 equals 0. So to solve this, I get cosine u equals 1/2. Over here, I get cosine u equals -1. Now, we do know that cosine is x over r. And so in both cases, we can think about our unit circle. If x is 1 and my radius is 2, you're getting pretty good at this by now, right? You're seeing that this is a 60-degree angle. But then you also remember there's another solution, right? Where else is x going to be +1 and r is going to be 2? That happens down here. X is still 1, r is still 2. And so that's going to be 60 degrees this direction. And so I take 360 minus 60. That's going to give me 300 degrees as a solution. Over here, where is x equal to -1 and the radius equal to -1? That happens over here. -1, 0. X is -1, my radius is 1. And so that's at 180 degrees. And so my final solutions then for this problem are 60 degrees, 180, and 300 degrees. Hopefully that is helpful. Just practicing these problems and seeing examples is really the way that's going to be helpful. So let me know if you have any questions. I'd be glad to help.